For the past couple weeks, we've been working on how to solve for the x-intercepts of a parabola algebraically. And we've been doing that by solving quadratic equations or degree 2 polynomial functions. And as we continue on that road, we need to stop and learn a new skill today that allows us to simplify complex radicals. So that's going to be our focus today. So let's talk about these three parabolas that I have in front of us here. So these parabolas, as you can see, here's our x and our y axis, and technically these should have arrows because they extend forever. This parabola has two x-intercepts. So this parabola has what we call two real zeros. Remember, we can call x-intercepts zeros, or we can call them roots, or x-intercepts. So we can call them all three of those names. So as you can see, this one has two real zeros. It crosses the x-axis at two real number values. One is at -2, the other is at +2. Then when you look at this parabola, again, let's label our x and y axis and then draw arrows at the end of the parabola so we know that it goes on forever. How many times does it hit the x-axis? It only hits it once. So as you can see, we only have one real zero. When you look at the third parabola, again, here's the x and y axes. Where does this parabola hit the x-axis? Well, it doesn't, at least not on the real number plane. So as you can see here, where all these real number values are, because this is a real number line, starting at 0 and then going off to in the right positive direction and then to the left in the negative direction. And this x-axis only includes all the real numbers. So what that means is that this specific parabola has 0 real x-intercepts. So what happens is when we solve this quadratic equation, we actually end up with imaginary solutions. So in this case, this parabola or this quadratic function has what we call two imaginary zeros. Two imaginary zeros, which means that this parabola does cross the x-axis, but only on the imaginary number plane. And you're going to learn more about what that means in Algebra 2 next year. For now, you just need to learn how to solve for those imaginary zeros. And yes, those imaginary zeros do exist. So to be able to find imaginary zeros, we need to understand the imaginary number I. I is a number, just like 1, 2, 3, 4, 5, -1, -2, 1/3, etc. I is a valid number. It totally exists. But it doesn't exist on the real number plane. It's not a real number. It's an imaginary number. So to be able to use I, we need to memorize something. You need to have memorized that I squared is equal to -1. So if I squared is equal to -1, that means that if I take off to the side here, I have I squared equal to -1. What if I wanted to solve for I? So right now, I squared equals -1. What if I wanted to know what I equals? I know that I squared is -1, but then what is just one I equal to? Well, to find that, we're going to have to square root both sides. The square root of I squared is simply I, because that square root cancels the square, is equal to the square root of -1. So I is equal to the square root of -1. So the reason why we need the imaginary number I is so that we can take the square root of negative numbers. So we can take the square root of negative numbers. So far in algebra, whenever we've come across the square root of a negative, we've just said, that's not a real number, and we pass it on by. After today, you actually need to be able to deal with the square root of a negative. So we're going to use this rule that we just learned that I squared is equal to -1. So check this out. For example 1, part A. We have the square root of -1. So remember that what we just figured out, or what we just learned, is that I squared is equal to -1. So what if I replace -1 with I squared? Then we just have to simplify the square root of I squared. So if I squared is equal to -1, I can replace -1 with I squared. Well, isn't I squared really just I times I? And then check it out. We have a group of 2 under a radical. Bring that out front of the radical. And then nothing's left in the radical, so we're done. So the square root of -1 is simply I. And doesn't that match what we just learned up here? So now let me show you how to find the square root of -49. So the square root of -49, what helps me when I do this is I separate the negative from the rest of the integer. So for example, -49, isn't that really just -1 times 49? Well, then I know how to break 49 down to 7 times 7. And then -1 is equal to I squared, so I replace -1 with I squared. And I know that I squared is really I times 7 times 7. Well, hey, I have a group of 2 i's. I can bring that out in front. I have a group of 2 7's. I can bring that out front of the radical. So I'm going to bring out the 7, and I'm going to bring out the I. So that means that the square root of -49 is 7i. Whenever you write a number that involves I, you always want to write the integer first, followed by the I. So writing 7i is correct. You never want to write I7. You're going to put 7i. So why don't you go ahead and use that method and apply it to the square root of -100 and the square root of -36 on your own. And then why don't you press pause on the video and then press play when you're ready to check your work. We can rewrite the square root of -100 as -1 times 100. I can replace -1 with I squared, and then I can rewrite 100 as 10 times 10. I can rewrite I squared as I times 10 times 10. So I have a group of 2 i's, a group of 2 10's. We're going to bring the I out in front, the 10 out in front, and we get 10i with nothing left under the radical. Part D, same thing with the square root of -36. So you should have written -1 times 36. Replace -1 with I squared, and 36 with 6 times 6. We can bring that 6 out in front. So 6 root I squared, and I squared is really I times I. Bring the I out in front, we're left with 6i. That's our final answer. And there we go. We've successfully found the square root of 4 different negative numbers. Now we need to apply this same concept to numbers that are negative but aren't perfect squares. So for example, the square root of -75. 75 itself isn't a perfect square. And so our radical isn't going to simplify out completely like in the previous problems. So we're going to rewrite, we're still going to use that same method. We're going to rewrite this as the square root of -1 times 75. Remember, I squared is equal to -1. That is our new best friend. We need to have that memorized. You need that for algebra 2. I squared is equal to -1. So we're going to replace -1 with I squared. And then we're going to start breaking 75 down. We need it to end up being something times something, and we're looking for groups of 2 because we're simplifying the square root. So 75 is really 25 times 3. We can break I squared down to I times I, 25 down to 5 times 5 times 3. Well, we have a group of 2 i's and a group of 2 5's. So we're going to bring an I out in front and a 5 out in front. But now we still have something left under the radical, this 3, so we have 5i times root 3. 5i times root 3 is our final answer. So the square root of -75 ends up being 5i root 3. And notice, just like in the previous problems, we end up with a positive answer. So whenever you take the square root of a negative, you always want to end up with a positive answer that involves I. So let's do part B together. So part B, we're going to break down the square root of negative 27 to negative 1 times 27. We're going to replace negative 1 with I squared, and then 27 is 9 times 3. I'm going to break down I squared to I times I. 9 is 3 times 3, and then we have our other 3. Again, we have groups of 2, 2 I's, 2 3's. We're going to bring those out in front. So we're going to have a 3 and an I out in front times root 3. So the square root of negative 27 is 3I root 3. Go ahead and try out part C and D on your own. Pause the video, press play when you're ready to check your answers. So in part C, you probably rewrote negative 150 as negative 1 times 150. You replace negative 1 with I squared. And then 150 is 15 times 10. I squared is really I times I. 15 is 3 times 5. And 10 is 5 times 2. I have a group of 2 I's and a group of 2 5's. So we bring out 5I, and we're left with that 3 times 2, still under the radical, and 3 times 2 is 6. So our final answer is 5I root 6. For part D, we're going to have negative 1 times 47. We're going to replace that negative 1 with I squared. I squared is really I times I, and then 47 can't be broken down. It's a prime number. So all we're bringing out front of the radical is I, and we're left with I root 47. That's our final answer. And that's all for today. For example 3, I just threw in a couple of equations, quadratic equations that have complex solutions, which means that the x-intercepts for both of these equations are actually imaginary numbers. So I'm going to show you what that looks like sometimes with a quadratic equation. So in the first one, x squared plus 100 equals 0. Because we only have 2 terms here, I'm going to go ahead and subtract 100 to the other side. And I'm going to have x squared is equal to negative 100. So to solve for x, we just square root both sides. The square root of x squared, these cancel out, so we're left with x equals. And then remember, when we square root both sides of an equation, we get a positive and a negative solution. So x is equal to plus or minus the square root of negative 100. So let's simplify that. So x is equal to plus or minus the square root of negative 1 times 100. Remember, I squared is equal to negative 1. So x is equal to plus or minus the square root. I'm going to replace negative 1 with I squared, and then 100 is really just 10 times 10. So x is equal to plus or minus the square root of I times 10 times 10. Circle your groups of 2. And bring that out in front. So x is equal to plus or minus, we're going to have 10I. So we have an x-intercept at x equals 10I and x equals negative 10I. So let's do the same thing with part B. So part B, x squared plus 75 equals 0. Again, we only have 2 terms, so let's just solve directly for x instead of using the quadratic equation or factoring, all that good stuff. We're just going to subtract 75 to both sides. So x squared equals negative 75. How do I get rid of the square? I square root both sides. So x is equal to, the square root cancels the square. I'm left with x is equal to the square root of negative 1 times 75. I'm going to replace negative 1 with I squared. And then I'm going to break down I squared to I times I. And then 75 to 25 times 3. I have a group of 2 i's I'm going to bring out in front. 25 has a square root. So x is equal to, I can bring out the square root of 25, which is 5. I can bring out an I, and then I'm left with root 3. Ooh, I forgot something here. When I square root both sides, how many answers should I have gotten? 2. How do I show those 2 answers? Plus or minus out in front of the radical. So I should have plus or minus 5i root 3.